del curso de Guía para Todos. Entonces, si quieren algún comentario, alguna duda sobre lo que vimos la semana 1, la semana 2, porque tuvimos ayer un día de descanso, y bueno, y capaz que tienen alguna duda, alguna pregunta para hacer, si no, arrancamos. Si me dan el ok, arrancamos. Espero que se vea bien. Vamos a probar el audio.
Welcome back. In the last 2 weeks, you learned what is AI and how to
Empezó.
build an AI.
Vamos a probar el audio.
Welcome back. In the last 2 weeks, you learned what is AI and how to build an AI project. This week, we'll look at the projects we talked about already.
Está acelerado, ¿no?
Welcome back. In the last 2 weeks, you learned what is AI and how to build an AI project. This week, we'll look at the projects we talked about already and talk about how projects fit in the context of a company, whether it's a for-profit, non-profit, or even within a government entity. For the sake of concreteness, I'll talk about building AI for companies, but equally apply no matter what type of organization you're in. Now, in case some of what you hear this week sounds like CEO level talk, don't be intimidated. This is actually useful for everyone to know that wants to help your company or help your organization improve using AI. And it does take maybe 2 or 3 years for a company to become good at AI, to embrace not just one AI project, but a sequence of valuable AI projects and become much more effective. But what I hope to do this week is help you paint a vision for where an organization can go over a longer period of time like that, but also end the week with very concrete short steps you can take right away. So let's get started. In detail, these are the topics you see this week. First is case studies of complex AI products. So rather than a single machine learning or data science module like what you saw last week, this week you see how multiple modules can come together to build a much more complex AI product, such as a smart speaker or a self-driving car. You also learn what are the major roles in an AI team. So if ever you think your company can build a large AI team with maybe many dozens or maybe even hundreds of people, what are the things these people will do? We'll start to paint a roadmap for what building an AI team might look like. Third, you also learn about the AI transformation playbook of how to help your company become good at AI, where it goes beyond doing 1 or 2 valuable projects, but about making your whole company good at AI and hopefully much more effective and valuable as a result. Finally, whereas some of these steps may take a small number of years to complete, we'll wrap up this week's videos with concrete suggestions on how you can take your first step right away toward building AI in your company. Beyond these major topics, we'll also have a couple of optional videos at the end where you see a survey of major AI application areas and techniques. So after this week's videos, I hope you have a good vision for how you can help your company use AI and also have first steps you can take right away. Let's get started by going on to the next video.
Bueno, antes que nada, ¿se vio? ¿Se escuchó bien, no? Esa es mi pregunta principal. ¿Sí? Joya. Bueno, después, es una introducción de lo que vamos a ver. Dijo que esta semana es más que nada ver cómo hacer que una empresa sea buena en inteligencia artificial, y vamos a ver paso a paso como esto es una cosa totalmente nueva, cómo integrar la inteligencia artificial en una empresa y que eso sea efectivo y rendidor, ¿no? Vamos a ver primero unos casos prácticos y después vamos a ver, bueno, vamos a ver casos prácticos de,
What does it feel like to work on a complex AI product where it isn't just using a single machine learning algorithm to map from A to B, but that learning algorithm is part of a bigger, more complex project or product? I want to start off this week with two case studies of building complex AI products. First, building a smart speaker so that you can start to understand what it might feel like to maybe someday work on a complex AI product within your own company. Let's get started. Smart speakers and voice-activated devices like these are taking the world by storm. And if you don't already have one in your home, maybe you buy one someday. I'd like to go through a case study of how you would write AI software to get a smart speaker to respond to a verbal command, such as, "Hey device, tell me a joke." For this example, rather than using Alexa or OK Google or Hey Siri or Hello Baidu as the wake word or trigger word, to be more device agnostic, I'm just going to use Hey device as the trigger word or wake word to wake up, say, a smart speaker, and let's say you want it to tell you a joke. So how do you build a piece of AI software to understand a command like this and execute on it? These are the steps needed to process the command. There are going to be 4 steps. Step 1 is the trigger word or the wake word detection. The speaker uses a machine learning algorithm to input the audio clip and output, did it just hear the wake word or the trigger word, hey device? So outputs 0 or 1. And once it hears the trigger word or wake word, once it hears hey device, it then has to perform step 2, which is speech recognition. So what the software has to do is take the audio of what came after hey device and map that to tell me a joke. This is also done with machine learning, whereas the first step here, use an A to B mapping to just tell it, did it hear the trigger word? This uses a different A to B mapping to map the audio to a text transcript of what you just said, which in this case is the 4 words, tell me a joke. Now, the algorithm has to figure out what you actually want by saying these 4 words. And so the third step is intent recognition. That means to take whatever you said and to figure out what you actually wanted to do. So today's smart speakers have a limited set of commands, such as they can tell a joke or they can tell the time. So you can say, hey device, what time is it? They can play music. They can sometimes have you make a phone call. They can tell you what's the weather, like, hey device, what's the weather tomorrow? And so what intent recognition does is take the 4 words the speech recognition's output and use another piece of AI software, another A to B mapping that inputs those 4 words and outputs which of these 5 or other intents do you have. So in this implementation of a machine learning algorithm, the input A is the text transcript, tell me a joke, and the output B is which of these 5 types of commands did the user just utter. Of course, your smart speaker may be able to understand even more commands than just these 5, in which case B would be whichever of the 5 or 20 or 100 commands your smart speaker knows how to execute. No matter how you ask the smart speaker to tell you a joke, hopefully the intent recognition components will recognize your intent correctly. So that you can also say, not just, hey device, tell me a joke, but also, hey device, do you know any good jokes? Or, hey device, tell me something funny. Turns out there are a lot of ways for you to ask a smart speaker for a joke, and a well-designed intent recognition system should recognize most of them. Finally, now that your smart speaker has figured out that you really want to hear a joke, the last step is that there'll be a software engineer that has written a piece of code to randomly select a joke and to play the joke back through the speaker. In other words, to execute the joke. Just for the record, my favorite joke is, why are there so many shocking results in AI? Because AI is the new electricity. Shocking electricity, get it? Hope you enjoyed that. And so, all right, and in seriousness, you can think of the 4 steps of the algorithm as these 4 steps, where the first step is trigger word detection, second step, speech recognition, then intent recognition, and then finally, execution of whatever command the user asks the smart speaker to execute. So the process of having 4 steps in an AI system like this, or multiple steps, this is sometimes called an AI pipeline, where you have multiple AI components. You actually have multiple machine learning components which process data one step after another. And it would not be unusual to have, say, 4 different teams in a company where each team focuses on one of the components of this AI pipeline. That's how we often organize projects within a large company. Let's now look at a more complex example. What if you issue a more complex command like, hey device, set timer for 10 minutes? These are the steps needed to process a command. First step, same as before, is trigger word detection. So input an audio and just let me know when someone said the trigger word, hey device. Then speech recognition, where you input the rest of the audio and transcribe the rest of the sound, the rest of the audio, set timer for 10 minutes. And now intent recognition has to input that text and output that your intent is that you want to set a timer. One difference between set timer for 10 minutes compared to the earlier example of tell me a joke is that you need to know how long to actually set the timer for. So in the execution step, you actually need to do 2 things. One is extract the duration. That means look at the text set timer for 10 minutes and pull out the phrase that tells you how long to actually set the timer for. And so if the user were to say, hey device, let me know when 10 minutes is up, then this extract duration step would have to pull out, again, the 10-minute phrase right there. And of course, there are lots of ways to ask for a 10-minute timer. You can also say, let me know when 10 minutes are up, or set alarm for 10 minutes from now. And hopefully the intent recognition and extract duration components will both be robust enough to recognize that all of these are different ways of asking for a 10-minute timer. And finally, to execute the command, there should be a specialized software component in the smart speaker that can start a timer with a set duration. And after it's extracted your intent and the duration, it will just start the timer with that duration so that the alarm goes off at the end of 10 minutes. Today's smart speakers have many functions. Other than the 2 we've talked about of telling jokes and setting a timer, here are some other functions that many smart speakers today can execute. And the key steps of executing these commands are trigger word or wake word detection, speech recognition to transcribe the text of the command, intent recognition to figure out which of these functions or which of these commands you want to execute, and then a specialized program to execute whichever command you uttered. One of the challenges of the smart speaker world is that if you want your smart speaker to have this many different functions, say 20 different functions, then you do need software engineering teams to write 20 specialized pieces of software. One to play music, one to set the volume, one to make calls, one to ask for the current time, one to convert units like from teaspoons to tablespoons, or to answer very simple questions, and on and on. And so it's actually quite a lot of work to write all of these specialized programs to execute all the different commands you might want to execute in step 4.
Disculpe,
and
pero
smart speakers today actually
no se ve la traducción y se achicó la pantalla.
program to execute whichever command you utter. Timer. Here are some other functions that many smart speakers today can execute. And the key steps of executing these commands are trigger word or wake word detection, speech recognition to transcribe the text of the command, intent recognition to figure out which of these functions or which of these commands you want to execute, and then a specialized program to execute whichever command you uttered. One of the challenges of the smart speaker world is that if you want your smart speaker to have this many different functions, say 20 different functions, then you do need software engineering teams to write 20 specialized pieces of software. One to play music, one to set the volume, one to make calls, one to ask for the current time, one to convert units like from teaspoons to tablespoons, or to answer various simple questions, and on and on. And so it's actually quite a lot of work to write all of these specialized programs to execute all the different commands you might want to execute in step 4. And smart speakers today actually do so many things that is difficult for many users to keep straight in their heads exactly what they can and cannot do. And so many smart speaker companies have been investing a lot in user training to try to let users know what are the things that smart speakers can do. Because on one hand, they can't do everything. There are a lot of things you can't ask smart speakers to do, such as please call my 3 friends and see when all of them are able to meet for dinner. And so it's been an ongoing process for the smart speaker companies to explain to users what they can and cannot do. Nonetheless, with what they can do, using voice to command these speakers is making life much more convenient for many people. I hope this video gave you a sense of what it takes to build a complex AI product such as a smart speaker. In order to help you better understand how these complex products work, let's go on to see a second case study of how to piece together multiple AI components to build a self-driving car. Let's go on to the next video.
Bueno, gente,
What does it feel like?
no sé si ¿se perdieron algo del video? Porque yo no sé si escucharon o vieron todo. Si es así, bueno, lo que muestra es que la verdad que el aparatito los aparatitos estos de reconocimiento de voz que hablan, en realidad tienen un conjunto muy grande de varios algoritmos. Primero, el que está escuchando todo el tiempo hasta que escucha la palabra clave para arrancar, que dice que después de que escucha la palabra clave, por ejemplo, hello, ok Google, o que lo tenemos en los celulares, que lo hacemos, después de eso, escucha el siguiente clip, ¿no? Escucha lo siguiente para interpretar cuál es el comando que tiene que ejecutar. Entonces depende de lo que sea, cada comando, cada fragmento de esa oración pueden ser un montón de inteligencias artificiales de distintos reconocimientos para que generen un tipo de funcionamiento. Después hay programación elemental, programación no de inteligencia artificial, sino para poder ejecutar ese código. Lo que está diciendo es que es muy difícil explicarle a los usuarios qué es lo que puede hacer y lo que no puede hacer. Puede darte el pronóstico, decirte la hora, programarte un cronómetro, pero no te puedes llamar a tus amigos para organizar una cena o algo así. Y todo lo que ustedes estaban pensando, que siempre dudaron, acá lo confirma. No lo quiero decir, pero ¿alguien me puede decir que lo que alguna vez pensaron que los escuchan? ¿No? ¿Nadie sospechó que los escuchaban alguna vez?
Sí, claro.
Sí, varias.
Hasta que, bueno, entonces también está, bueno, eso lo vamos a ver en la 4ª semana, ¿no? El asunto de la ética, porque uno puede hacer un dispositivo así ¿cómo se llama? Con una trampa para estar escuchando lo que la gente está diciendo hasta que dice, no, la verdad la excusa es porque yo quiero escuchar cuando arranca. Entonces la inteligencia artificial también tiene ese lado, ¿no? Y si nosotros vamos a trabajar en inteligencia artificial, ya tenemos que plantearnos de tener una ética para respetar los datos de las personas y para no generar después ¿cómo se llama? Que la gente tenga recelo de usar, que la gente tenga miedo, que la gente tenga, ¿entendés? Lo que vimos en la semana 1, la gente tenía miedo a la inteligencia artificial general, ¿no? El robot que nos va a venir a dominar. Entonces, si nosotros como ingenieros de inteligencia artificial o como desarrolladores eh, no mantenemos la ética y no vamos haciendo las cosas como se deberían ser, podemos generar eh, una reacción. Yo estoy hablando en voz alta, ¿no? Estoy pensando, ustedes, y me gustaría escuchar algún comentario, qué opinan.
Hola, hola, ¿se escucha? Yo
Sí,
quería consultar respecto a, por ejemplo, con esto del tema de la implementación de sistemas que sirven para, entre comillas, violar o vulnerar la privacidad de las personas. Supongamos que tenemos que autodeterminar eso. ¿Quién lo regularía?
y la verdad que no hay un ente que regule todo eso, porque eso es todo muy nuevo, pero viste cuando vos te instalás ponés el Gmail en el Android, que firmás sacás que firmás que estás de acuerdo, que estás de acuerdo con las condiciones de un dispositivo, y vos lo leyeras
Sí,
todo eso, todo completo,
Sí,
detallado, no lo
perdón que te interrumpo, ¿no? Pero yo creo que 9 de 10 jamás leen el convenio o lo que firman para dar
yo creo que,
consentimiento, no cualquier tipo
yo creo que 10 de
de
10.
aplicación.
Yo creo que 10 de
Perdón, Emi, ¿puedo decir algo?
sí.
Por un lado están los datos, que ahí está protegido por la ley que a veces se cumple, a veces no, ya sabemos, pero la ley de protección de datos personales, digamos, ¿no? Es decir, de donde uno saca los datos y donde uno pone sus datos para que sean usados, que es justamente lo que están ustedes hablando ahora. Es decir, cuando vos aceptás las condiciones de uso, estás diciendo un montón de cosas que no lee nadie prácticamente, como se dice. Y ahí, y si uno se fija, cuando uno instala las aplicaciones, te dice, mira, vamos a acceder a los datos, las fotos, los contactos, o sea, te vamos a ver todo el celular si tenemos ganas, y por ahí te sacamos los datos. Y así es como, justamente, vos estás dando el consentimiento de que te saquen o usen tus datos, ¿sí? Después, uno por la ley de protección de datos puede pedir a un determinado lugar, si no, mira, quiero saber qué datos sabés de mí, y te lo tienen que responder, porque eso es por ley. Ahora, sobre inteligencia artificial en particular, de lo que hace un algoritmo, lo que analiza, justamente no hay mucha legislación en ese caso, ¿sí? Hay que separar los datos de lo que es el procesamiento, justamente. Y ahí también hay toda una controversia en cuanto a qué hace el algoritmo, cómo lo hace, por qué toma determinadas decisiones. Sí, acuérdense de la historia de Asimov de Yo Robot, ¿sí? Es decir, las tres leyes famosas de la robótica. ¿Sí? Es decir, se toma la decisión bajo criterios de una lógica, de un algoritmo, y eso después probado en el campo, en las diferentes condiciones, puede tener condiciones inaceptables para lo que nosotros consideramos que tienen que ser las cosas, ¿no? Entonces, sobre eso todavía hay algunas cosas que pero se va avanzando sobre la marcha, digamos, ¿no? No hay leyes en particular.
Porque eso es todo muy nuevo, ¿no?
Perdón, ¿no? Pero la moral y la ética contra un algoritmo, o sea, ¿cómo
Bueno,
determinamos
es
entonces?
justamente el planteo, es decir, cómo hacer para que el algoritmo tenga ética y moral, digamos, ¿no? Que es lo que dice, sí, salvando la distancia para no hacerla muy larga, la película Yo Robot, es decir, el robot detectó en el caso de que se estaba ahogando dos personas, a quién salvaba primero, y salvó a un adulto en vez de a un hijo por las probabilidades, ¿no? Entonces, justamente, sobre eso no hay legislación, y no hay control tampoco, ¿no? Entonces, ahí es todo un debate abierto que recién está comenzando,
Claro, pero
justamente.
lo que se habla acá, por ejemplo, en este curso, en la semana 4 es que la ética la tenemos que implementar ya cuando estamos nosotros haciendo el algoritmo, cuando vemos los
Claro,
resultados,
en el diseño, digamos.
que contemos los datos. Nosotros tenemos que tener el concepto
Exacto,
¿entendés?
hay que, digamos, de alguna manera volcarlo en la
Claro,
lógica.
Y nosotros mismos tendríamos que controlar a nuestros compañeros o en un proyecto o decir, no, esto todo muy lindo, pero no es ético. ¿Entendés? Entonces tenemos que estar en nosotros. Digo nosotros como los que vamos a trabajar en esto, los que vamos a estar en este campo, ¿no? Todos los que estamos acá y todos los que vendrán y los que... Entonces, eh, la mentalidad la tenemos que cambiar nosotros. Nosotros tenemos que eliminar el sesgo, y tenemos que tener, ser abiertos de mente para no generar que un algoritmo... Pensar de que tenemos que beneficiar y no perjudicar, eso es lo que tenemos que pensar. Bueno, esto está para debatir un par de horas, ¿no? Bueno, continuamos. Ahora vamos a ver otro caso de estudio que ya... Voy a admitir todos.
One of the most
Espera un
exciting
minutito.
products of the AI One of the most exciting products of the AI era is the self-driving car. Self-driving cars are also one of the most mysterious things you hear about in AI these days. In this video, what I want to do is share with you a somewhat simplified description of a self-driving car so that you understand how you can piece together multiple AI components in order to build these amazing things. Let's get started. These are the key steps for deciding how to drive your self-driving car. The car will take as input various sensors such as pictures of what's in front of the car or to the sides or behind, as well as maybe radar or LiDAR, meaning laser sensor readings. Given this input of a picture and maybe other things, it then has to detect other cars. So given that, hopefully you'll figure out there's a car there, as well as where are the pedestrians, because we want to avoid other cars as well as avoid pedestrians. Both car detection and pedestrian detection can be done with machine learning using input-output or A to B mappings that takes as input the picture and maybe radar and LiDAR sensor inputs and tells us where are the other cars and pedestrians. Finally, now that you know where are the other cars and where the pedestrians, you can then feed this information into another specialized piece of software. It's called a motion planning piece of software that plans the motion or plans the path that you want your car to take so that you can make progress toward your destination while avoiding any collisions. And once you've planned out the motion for your car, you can then translate that into specific steering angle for a steering wheel and acceleration and brake commands. So how much to step on the gas pedal and how much to brake in order to get your car to move at the desired angle as well as speed. Let's look at the three key steps of car detection, pedestrian detection, and motion planning in more detail. Car detection uses supervised learning. So you've already seen how a learning algorithm can take as input pictures like these and output the detected cars. For most self-driving cars, rather than using only a front-facing camera, so a camera that looks forward, also often use cameras that look to the left, to the right, as well as to the back, so you can detect cars not just to the front, but all around it. And this is usually done using not just cameras, but other sensors as well, such as radar and LiDAR. Next is pedestrian detection, and using a pretty similar type of sensors as well as techniques, self-driving cars can detect pedestrians. Finally, I briefly mentioned a motion planning step. So what is that? Here's an example. Let's say you're driving your car and there's this light blue car in front of you. The motion planning software's job is to tell you what is the path shown here in red you should drive in order to follow the road and not have an accident. And so the motion planning software's job is to output the path as well as speed at which you should drive your car in order to follow the road. And the speed should be set so that you don't run into the other car, but you also drive at a reasonable speed on this road. Here's another example. If there's this gray car parked on the right side of the road, so you want to overtake this stopped car, then the motion planning software's job is to plot a path like that to let you veer a little bit to the left and safely overtake a stopped car. So far, I've given a rather simplified description of self-driving as comprising mainly these three components. Let's look at a bit more detail of how an actual self-driving car might work. This is a picture you've seen so far. Input image, radar, LiDAR, sensor readings, do car detection and pedestrian detection, and that is then fed to motion planning to help you select your path and speed. Now, in a real self-driving car, you would usually use more than just cameras, radar, and LiDAR. Most self-driving cars today will also use GPS to sense its position, as well as accelerometers, sometimes called an IMU, basically means accelerometers and gyroscopes, as well as a map, because we know that cars are more likely to be found on the road, pedestrians are more likely to be found on sidewalks, although they are sometimes found on the road as well. And all this is usually additional information that's fed in to detect cars and pedestrians, as well as other objects we'll talk about in a second. Rather than just detecting cars and pedestrians, in order to drive safely, you also need to know where these cars and pedestrians are going in the future. So another common component of self-driving cars is trajectory prediction, where there's another AI component that tells you not just the cars and pedestrians you found, but also where they're likely to go in the next few seconds so you can avoid them even as they're moving. To drive safely requires more than just navigating other cars and pedestrians. You also need to know where are the lanes, so you might detect lane markings. If there's a traffic light, you also need to figure out where's the traffic light and is it showing a red, yellow, or green signal. And sometimes there are other obstacles, such as unexpected traffic cones, or maybe there's a flock of geese walking in front of your car that needs to be detected as well, so that your car can avoid even other obstacles in cars and pedestrians. On a large self-driving car team, it would not be that unexpected to have a team or maybe a few people working on each of the boxes shown here in red. And it's by building all of these components and putting them together that you can build a self-driving car. As you can tell, both from this rather complex example of an AI pipeline, as well as the earlier example of the full-step AI pipeline for the smart speaker, sometimes it takes a team to build all of these different components of a complex AI product. What I'd like to do in the next video is share with you what are the key roles in large AI teams. And if you're either a one person or a small AI team now, that's okay, but I want you to have a vision of what building a large AI team, maybe in the distant future, might look like. Let's go on to the next video.
Bueno, en este ejemplo es más o menos un ejemplo más de la complejidad que tiene armar un producto final, ¿no? Un producto final con inteligencia artificial significa que en este caso el auto, aparte del auto autónomo, se está desarrollando, todavía no hay pruebas, aunque hay experimentos, hay desarrollos, pero todavía no hay nada que sea muy seguro. Lo que dicen es que en un futuro, lo que nosotros conocemos ahora como, capaz que nosotros no, nuestros hijos tampoco, capaz que nuestros nietos en algún momento no manejen más, no manejen más, que sean todos, imagínense esto, que sean todos autos que se manejen solos, que se comuniquen entre ellos por distintos sensores y que vos no tengas un auto, contrates un servicio que te lleve de un lado al otro, a otro lado, lo dejas ahí y ese lo agarra otra persona y eso es lo que es una cosa de ciencia ficción que no es tanto de ciencia ficción, sino que se puede llegar a desarrollar. Bueno, pero me desvío del tema. Vamos al otro video. Los roles dentro de una estructura de IA.
You saw from the last two videos that some AI products may require a large AI team, maybe with 100 engineers or sometimes many more than 100 to build. What I'd like to do in this video is share with you the typical roles and responsibilities of a large AI team like this, so you can better understand the types of work needed to build these complex AI products. Now, even if you will be working in a much smaller team, maybe a 1 or 2 or 5 person team for the foreseeable future, I hope this video will still be useful to you because it helps give you a sense of the different types of work that an AI team might need to do, even if you end up executing on this type of work with a much smaller team. One caveat, because AI is evolving so fast, the job titles and roles and responsibilities are not yet 100% defined, and they are a little bit different across different companies. So your company may use the job titles differently than what I'm presenting here, but I want to share with you how job titles are often used in many companies, so that if you're someday building up your own AI team or you hear about these roles, you would have at least some default understanding of what these job titles mean. So let's get started. Many AI teams will have software engineers in them. So for example, for the smart speaker, we needed to write specialized software to execute on the joke, or to set a timer, or to answer questions about today's weather. So those are traditional software engineering tasks. Or if you're building a self-driving car, to make sure that your self-driving car software is reliable and doesn't crash. These are software engineering tasks. So it's not uncommon for AI teams to have a large fraction, sometimes 50%, sometimes much more than 50% of software engineers in them. The second common role is the machine learning engineer. And so a machine learning engineer might write the software responsible for generating the A to B mapping, or for building other machine learning algorithms needed for your product. So they might gather the data of pictures of cars and positions of cars, train a neural network or train a deep learning algorithm, and work iteratively to make sure that the learning algorithm is giving accurate outputs. Another role that you sometimes hear about is the machine learning researcher. The typical role of the machine learning researcher is to extend the state of the art in machine learning. Machine learning and AI more broadly are still advancing rapidly, and so many companies, for-profit, non-profit, will have machine learning researchers responsible for extending the state of the art. And some machine learning researchers will publish papers, but many companies also have machine learning researchers that do research but are less focused on publishing. There's one other job title that's sort of in between these two, which is the applied machine learning scientist, which lives somewhere between machine learning engineer and machine learning researcher. And the machine learning scientist kind of does a bit of both. They're often responsible for going to the academic literature or the research literature and finding the state-of-the-art techniques and finding ways to adapt them to the problem that you are facing, such as how to take the most cutting-edge trigger word or wake word detection algorithm and adapt that to your smart speaker. Let's look at some more roles. Today, there are a lot of data scientists working in industries, and the role of data scientist is not very well defined, and the meaning is still evolving today. I think one of the primary responsibilities of data scientists is to examine data and provide insights, as well as to make presentations to teams of executives in order to help drive business decision making. There are also data scientists today doing other tasks. So there are also data scientists today whose work looks more like the machine learning engineer that I described on the previous slide. And the meaning of this job title is still evolving today. With the rise of big data, there are also more and more data engineers whose main role is to help you organize your data, meaning to make sure that your data is saved in an easily accessible, secure, and cost-effective way. So why is saving data such a big deal? Can't you just save on a hard disk and be done with it? In some companies, data volumes have gotten so big, there's actually quite a lot of work to manage them. To give you a sense of the scale, in computer science, 1 MB stands for 1 megabyte. And so a typical song on your music player, like a typical MP3 file, may be a few megabytes, say 5 megabytes would be a not unusual MP3 file size. 1,000 megabytes is called a gigabyte. 1,000,000 megabytes is called a terabyte, and 1,000,000,000 megabytes is called a petabyte. With today's hard disk sizes, saving a few megabytes is not a big deal. It's just like a MP3 file. But storing 1,000 megabytes, also called a gigabyte, starts to be a bit slower. A typical hour-long movie that you stream over the internet may be about a gigabyte, so that's quite a lot of data. And to give you a sense of the scale, a self-driving car may collect multiple gigabytes of information every single minute of operation. So it's as if every minute the self-driving car generates enough data to store multiple hour-long movies. So self-driving cars actually generate a lot of data, and saving the data from many days or weeks or months or years of operation starts to require serious data engineering. A terabyte is 1,000 times bigger than that, and a petabyte is yet another 1,000 times bigger than that. I've led teams that were responsible for saving several petabytes of information per day, but other than pretty large internet companies, it's not that common for a company to generate multiple petabytes of information per day. And as you move down this scale to bigger and bigger data sets, it becomes harder and harder to make sure the data is stored in an easy, accessible, secure, and cost-effective way, which is why data engineers become more and more important. Finally, you also hear some people refer to AI product managers, whose job is to help decide what to build. In other words, to help figure out what's feasible and valuable. Traditional product manager's job was already to decide what to build, as well as sometimes some other roles, but the AI product manager now has to do this in the AI era and are needing new skill sets to figure out what's feasible and valuable in light of what AI can and cannot do today. Because the field of AI is still evolving, none of these job titles are completely nailed down in stone, and different companies will use these job titles somewhat differently. But I hope this gives you a sense of some of the different types of work needed to build very complex AI products, as well as where some of the job titles are evolving. To finish though, I want to re-emphasize that you can get started with a small team. You don't need 100 people to do most AI projects. And so whether you just have one software engineer working with you, or just a single machine learning engineer, or just a single data scientist, or maybe nobody but yourself, if either you or an engineer working with you has taken some online courses on machine learning or deep learning or data science, that's often enough for you by yourself or for you and an engineer to start looking at some smaller volumes of data, start drawing some conclusions, or start training some machine learning models to get going. So even though I've tried to paint here a vision for what a large AI team might look like, even if you have only a small AI team, could be nobody but yourself, I would still encourage you to get started and start exploring what are projects you could do. In this video, you saw what an AI team might look like, but when you look at a bigger company, an AI team doesn't live in isolation. So how does an AI team fit into a bigger company to help the whole company become good at AI? You might remember that in week 1, I briefly alluded to an AI transformation playbook, which is a roadmap for you to help a company, to help maybe a great company become great at AI. Now that you've learned what is AI, how to do AI projects, and even what AI teams and companies and complex AI projects and companies might look like, let's return to the AI transformation playbook and go much deeper into the individual steps of the playbook so that you can understand what it takes to help a company over maybe a small number of years become good at AI and hopefully become much more valuable and much more effective along the way. Let's go on to the AI transformation playbook in the next video.
Bueno, la verdad es que es muy interesante, por ejemplo, en el caso mío, ¿no? En el caso mío, con lo que estamos trabajando, somos 3. Así que entre los 3 estaríamos ocupando todos los puestos que nombró Andrew, ¿no? Pero es la verdad, no hace falta tener un equipo de 100 personas para empezar a trabajar o para hacer. Uno mismo, uno solo puede hacer todo eso, de encargarse de dónde vas a guardar los datos. Supuestamente que cuando uno está trabajando solo no es tan dramático, no hay tanta información o no empezás con tantos datos. A medida que vas creciendo, sí. Pero también, como dice Andrew, capaz que vos y un amigo o vos que sabe programar, que hacer un par de cursos, buscar información, descargarse algún algoritmo precocinado de GitHub, armar un dataset, fijarse dónde vas a guardar. Es muy complejo, abarca muchos temas y a medida que uno va creciendo, después sí, hay gente que se va a ir especializando en algunos temas, ¿no? ¿Algún comentario? ¿Alguien quiere comentar algo? Pero si no, vamos.
No, sigamos.
No, venimos bien. Yo digo porque ese me quedo como esperando una respuesta y me cuesta todavía, no me acostumbro mucho todavía a la virtualidad.
How can you help your company become good at AI? How can you help your company become good at AI? Based on my experience starting leading the Google Brain team, as well as Baidu's AI group, which were respectively the leading forces for helping Google and Baidu become good at deep learning and AI, I've spent a lot of time thinking about what it takes to help a great company become a great AI company, and I wound up writing an AI transformation playbook to help other companies on this journey. In this video, I'd like to share with you the details of the AI transformation playbook so that you can better understand what it might take for your company to become good at AI. In case some of this seems like things that only CEOs need to know, I think that's not the case. It's useful for everyone in the company to understand what it might take for your work to impact not just a few projects, but maybe have a bigger impact on the company as a whole. Let's get started. Here are the 5 steps of the AI transformation playbook. We'll dive into greater detail in a little bit, but briefly, step 1 is for your company to execute pilot projects to gain momentum, to start to know what it feels like to work on AI projects. Step 2 is to build an in-house AI team. Step 3 is to provide broad AI training, not just to engineers, but to many levels within the company, including executives. Step 4 is to develop your AI strategy. And step 5 is to develop internal and external communications about your company and AI. The way your company will execute the steps may not be totally sequential, and so the different steps may overlap, but this numbering gives a maybe rough sense of the order in which I think you could do these steps. In this video, we will go in greater depth on the first 3 of these 3 steps, and the next video will cover steps 4 and 5. Let's start with step 1, executing pilot projects to gain momentum. If you want your company to gain momentum with AI, the most important consideration for the initial project or projects is for them to be successful rather than necessarily be the most valuable. For example, when I was leading the Google Brain team, there was still a lot of skepticism at that time about deep learning. So my first internal customer was Google's speech recognition team. And speech recognition is nice to have. It's useful, but it's actually not the most important or valuable project for the company's bottom lines. It's not as valuable as, for example, web search or online advertising. But by having my team make the Google speech team more successful, it started the flywheel turning, helped us get momentum, because then the peers, the other teams that are brothers and sisters of the speech team started to see my team make the speech team more successful. And so they also started to gain favor in AI and wanted to work with us. So my second internal customer was the Google Maps team, to improving the quality of the maps data using deep learning. And with the first and second successes, I then started other conversations with the online advertising team, for example. So when selecting your initial project, try to pick something that you think has a good chance of success that can start the flywheel turning, even if it may not be the most valuable project that you could eventually do for the company. Because the goal of the first few projects is just to gain momentum, is also nice if you can pick something that can show traction within 6 to 12 months. So you can start the flywheel turning quickly. Finally, your first 1 or 2 pilot projects can be either in-house or outsourced. If you do not yet have a large in-house AI team, might be possible, might even be advisable to outsource some or all of your first couple AI projects in order to get more expertise in-house and to let you start building that momentum faster. Now, beyond a certain point, you will need your own in-house AI team to execute a long-term sequence of maybe many dozens of AI projects. And so step 2 is to build an in-house AI team. A lot of companies are organized like this, where there's a CEO and multiple business units, which I'm going to abbreviate with BU, that reports up to the CEO. So what I recommend for most companies is to build a centralized AI team, and then to take the talent in the matrix organization and to matrix them into these different business units to support their work. Why a centralized AI team? Let's take an example. Maybe this unit is your gift card business unit, and the BU leader may be great at whatever he or she does. They may be great at the gift card business. But unless he or she is knowledgeable about AI and knows how to build, retain, and manage an AI team, it may be very difficult for that business unit leader to hire and retain and appropriately manage their own AI talent. So in that case, I think your odds of success will be much higher if you find an AI team leader that can be responsible for consistent company-wide standards for recruiting, retention, have a centralized AI team to give the team a community to talk to each other about how AI applies to your business vertical. It may be more efficient to take the AI talent in your centralized AI unit and matrix them into the gift card business unit so that your AI talent can work together with the gift card domain experts in order to develop interesting AI projects together. One other responsibility for the AI unit is to build company-wide platforms. If there are software platforms or other tools or data infrastructure that could be useful for the whole company, then a single business unit may not have the resources or the incentive to build these company-wide platforms or resources that can support the whole company, but a centralized AI team may be able to help build these company-wide tools or platforms that can help multiple business units. Finally, this new AI business unit can be under the CTO, the CIO, the Chief Data Officer, or the Chief Digital Officer, or it could also be under a new Chief AI Officer. The CAIO, Chief AI Officer, is a role that I'm seeing more and more often in different companies, but if some other senior executive has the right skill set, they could also manage the AI unit. Finally, one last recommendation, which is that I think it is helpful if, to get the AI unit started, the company or the CEO provides funding to build up the AI unit rather than require the AI unit to get funding from the business units. Eventually, after the initial investment and after the initial ramp up, the AI unit will have to show its value that it's creating for the business units, but having CEO inject funding at the outset so they can get going will often help you get that initial momentum much faster. In addition to building an in-house AI team, I also recommend that you provide broad AI training. Now, for a company to become good at AI, it's not just that you need engineers to know AI, you need multiple people at multiple levels of the company to understand how AI interacts with their roles. For example, for executives and senior business leaders, I recommend that they learn what AI can do for your enterprise, that they learn the basics at least of AI strategy, and they learn enough about AI to make resource allocation decisions. So how much training should executives and senior business leaders receive? I think that numbers of hours of training is not a very good way to measure training, but with that caveat, I think you can deliver a lot of this training with maybe 4 hours or so of training. Leaders of divisions working on AI projects also need to know how to interact in their role with AI. I think these leaders would need to understand how to set project direction, so how to conduct technical and business diligence.
Perdón, consulta.
Resource allocation.
¿Cómo se fragmenta ese tipo de información?
Ah, hola, hola, disculpen, estaba muteado, estaba hablando solo. A ver, vos preguntabas, ¿me podés repetir la pregunta, por favor? Hola, hola. ¿Me escuchan o no me escuchan?
La mitad del video, más o menos, creo que se perdió el sonido, después de la primera línea, digamos.
Pero alguien preguntó algo. Yo
Sí, alguien preguntó
lo
algo.
frené para hablar y estaba muteado y me quedé hablando solo. Por eso no me escuchaban, estaba frenado. Alguien había preguntado algo sobre cómo se diferenciaban, no me acuerdo bien la pregunta, pero yo estaba explicando que lo que dice que todos en una empresa tienen que tener conocimiento de lo que puede hacer una inteligencia artificial o lo que no puede hacer una inteligencia artificial y dónde poder aplicarlo. No hace falta que sean expertos, que sean ingenieros en inteligencia artificial, sino que tengan los conocimientos básicos o saber qué tipo de datos se necesitan y dónde se puede aplicar. Era eso. Yo pensé que era, no sé quién preguntó si le quedó más claro o no. No sé quién preguntó. Bueno, continuamos. Listo. Y no me muteo, así que cuando hablo.
Decisions at the division level, as well as how to track and monitor progress of AI projects. So this type of training, I think, would take at least 12 hours, although again, number of hours is not a great metric for tracking how much you're learning. Finally, many companies are hiring AI, but we're also not underestimating training up for software engineers.
Ay, se fue todo, ¿no?
Sí, no se escucha nada compartiendo.
No se escucha nada y tampoco se ve nada.
Pantalla negra.
Sí. Manual de estrategias. Aguanten un segundo que no sé qué me pasó.
Te hago una consulta. ¿Por
Sí,
qué no terminamos de ver el video y después hacemos la pregunta al finalizar el video?
sí, la culpa es mía, discúlpenme.
No, para
Ahora,
poder organizarlo.
¿qué es lo que se está viendo? Díganme, por favor, porque yo cuando pongo compartir no veo lo que estoy compartiendo. ¿Se ve el manual de estrategia de transformación de IA?
Sí.
Ah, bueno. Listo. Lo retrocedo al video, más o menos por donde quedó que hicieron la pregunta. Y le doy play y no me muteo. Así que.
In-house AI team
Esperen.
might be possible, might even be
¿Ahí está bien
advisable
o
to
quieren retroceder
outsource
más?
some or all of your first couple AI projects in order to get more expertise in-house and to let you start building that momentum faster. Now, beyond a certain point, you will need your own in-house
atrás,
AI
por favor.
team to
Lo
execute.
pongo de entrada, listo, listo. No perdemos, tenemos tiempo.
How can you help your company become good at AI? Based on my experience starting leading the Google Brain team, as well as Baidu's AI group, which were respectively the leading forces for helping Google and Baidu become good at deep learning and AI, I've spent a lot of time thinking about what it takes to help a great company become a great AI company. And I wound up writing an AI transformation playbook to help other companies on this journey. In this video, I'd like to share with you the details of the AI transformation playbook so that you can better understand what it might take for your company to become good at AI. In case some of this seems like things that only CEOs need to know, I think that's not the case. It's useful for everyone in the company to understand what it might take for your work to impact not just a few projects, but maybe have a bigger impact on the company as a whole. Let's get started. Here are the 5 steps of the AI transformation playbook. We'll dive into greater detail in a little bit, but briefly, step 1 is for your company to execute pilot projects to gain momentum, to start to know what it feels like to work on AI projects. Step 2 is to build an in-house AI team. Step 3 is to provide broad AI training, not just to engineers, but to many levels within the company, including executives. Step 4 is to develop your AI strategy. And step 5 is to develop internal and external communications about your company and AI. The way your company will execute the steps may not be totally sequential, and so the different steps may overlap, but this numbering gives a maybe rough sense of the order in which I think you could do these steps. In this video, we will go in greater depth on the first 3 of these 3 steps, and the next video will cover steps 4 and 5. Let's start with step 1, executing pilot projects to gain momentum. If you want your company to gain momentum with AI, the most important consideration for the initial project or projects is for them to be successful rather than necessarily be the most valuable. For example, when I was leading the Google Brain team, there was still a lot of skepticism at that time about deep learning. So my first internal customer was Google's speech recognition team. And speech recognition is nice to have. It's useful, but it's actually not the most important or valuable project for the company's bottom lines. It's not as valuable as, for example, web search or online advertising. But by having my team make the Google speech team more successful, it started the flywheel turning, helped us get momentum, because then the peers, the other teams that are brothers and sisters of the speech team started to see my team make the speech team more successful. And so they also started to gain faith in AI and wanted to work with us. So my second internal customer was the Google Maps team, to improving the quality of the maps data using deep learning. And with the first and second successes, I then started other conversations with the online advertising team, for example. So when selecting your initial project, try to pick something that you think has a good chance of success that can start the flywheel turning, even if it may not be the most valuable project that you could eventually do for the company. Because the goal of the first few projects is just to gain momentum, is also nice if you can pick something that can show traction within 6 to 12 months. So you can start the flywheel turning quickly. Finally, your first 1 or 2 pilot projects can be either in-house or outsourced. If you do not yet have a large in-house AI team, might be possible, might even be advisable to outsource some or all of your first couple AI projects in order to get more expertise in-house and to let you start building that momentum faster. Now, beyond a certain point, you will need your own in-house AI team to execute a long-term sequence of maybe many dozens of AI projects. And so step 2 is to build an in-house AI team. A lot of companies are organized like this, where there's a CEO and multiple business units, which I'm going to abbreviate with BU, that reports up to the CEO. So what I recommend for most companies is to build a centralized AI team, and then to take the talent in the matrix organization and to matrix them into these different business units to support their work. Why a centralized AI team? Let's take an example. Maybe this unit is your gift card business unit, and the BU leader may be great at whatever he or she does. They may be great at the gift card business. But unless he or she is knowledgeable about AI and knows how to build, retain, and manage an AI team, it may be very difficult for that business unit leader to hire and retain and appropriately manage their own AI talent. So in that case, I think your odds of success will be much higher if you find an AI team leader that can be responsible for consistent company-wide standards for recruiting, retention, have a centralized AI team to give the team a community to talk to each other about how AI applies to your business vertical. It may be more efficient to take the AI talent in your centralized AI unit and matrix them into the gift card business unit so that your AI talent can work together with the gift card domain experts in order to develop interesting AI projects together. One other responsibility for the AI unit is to build company-wide platforms. If there are software platforms or other tools or data infrastructure that could be useful for the whole company, then a single business unit may not have the resources or the incentive to build these company-wide platforms or resources that can support the whole company, but a centralized AI team may be able to help build these company-wide tools or platforms that can help multiple business units. Finally, this new AI business unit can be under the CTO, the CIO, the Chief Data Officer, or the Chief Digital Officer, or it could also be under a new Chief AI Officer. The CAIO, Chief AI Officer, is a role that I'm seeing more and more often in different companies, but if some other senior executive has the right skill set, they could also manage the AI unit. Finally, one last recommendation, which is that I think it is helpful if, to get the AI unit started, the company or the CEO provides funding to build up the AI unit rather than require the AI unit to get funding from the business units. Eventually, after the initial investment and after the initial ramp up, the AI unit will have to show us value that it's creating for the business units. But having CEO inject funding at the outset so they can get going will often help you get that initial momentum much faster. In addition to building an in-house AI team, I also recommend that you provide broad AI training. Now, for a company to become good at AI, it's not just that you need engineers to know AI, you need multiple people at multiple levels of the company to understand how AI interacts with their roles. For example, for executives and senior business leaders, I recommend that they learn what AI can do for your enterprise, that they learn the basics at least of AI strategy, and they learn enough about AI to make resource allocation decisions. So how much training should executives and senior business leaders receive? I think that numbers of hours of training is not a very good way to measure training, but with that caveat, I think you can deliver a lot of this training with maybe 4 hours or so of training. Leaders of divisions work on AI projects also need to know how to interact in their role with AI. I think these leaders would need to understand how to set project direction, so how to conduct technical and business diligence, how to make resource allocation decisions at the division level, as well as how to track and monitor progress of AI projects. So this type of training I think would take at least 12 hours, although again, number of hours is not a great metric for tracking how much you're learning. Finally, many companies are hiring AI talent from outside, but I would also not underestimate the importance and the impact of training up your existing engineering workforce with AI skills. For a software engineer to become proficient at AI does take a while, so plan for maybe at least 100 hours of training. But I'm seeing many companies provide training to help engineers learn to build and ship AI software, to gather and manage data, as well as help them become effective at executing on specific AI projects. The world today does not have nearly enough AI engineers, and so in-house training is a key part of many companies building up of their in-house AI capabilities. Finally, how do you get all this training done? Thanks to the rise of online digital content, ranging from, of course, online courses to also books and YouTube videos and blog posts, there is a lot of great content online about all of these subjects, and I think a good CLO should work with experts to curate this type of content and motivate the teams to complete these learning activities rather than necessarily create content, which is a much more expensive thing to do. So with steps 1 to 3 of the AI transformation playbook, I hope that your company will be able to start to execute on initial projects, build a team, provide the training, and really start to get a lot of momentum going in terms of helping your company become more valuable or more effective using AI. Looking at the broader picture, AI also affects company strategy and how you align different stakeholders, including investors, employees, customers, with this transformation of the company. Let's go on to the next video to talk about AI strategy.
Bueno, no sé si ahora que lo vimos una vez y medio quedó más claro. No sé si hay alguna duda o algún comentario. Que bueno, la cuestión es que primero que uno tiene que empezar a hacer algo, ¿no? Que capaz que no sea lo más valioso para la empresa, como lo había dicho antes, ¿no? Pero hacer algo que tenga éxito. Después, una vez que tratar de formar un equipo interno de inteligencia artificial, implementarlo para que pueda ayudar y complementarse con las otras secciones de la empresa que hay. Alguien había preguntado si esto era solamente para empresas grandes o no. En realidad es para todo tipo de empresa que quiera empezar a implementar inteligencia artificial dentro de, quiere hacer una empresa que sea buena en inteligencia artificial. Entonces tienen que armar un equipo que, y lo que dice que todos, desde el CEO la gente que trabaja en las distintas secciones, en todos lados, tienen que tener un conocimiento. Capaz que el CEO no necesita ser un experto, pero que los demás, que todos tengan, que sepan qué es lo que una inteligencia artificial puede hacer o no puede hacer, qué es lo que necesita una inteligencia artificial, qué datos necesitan obtener, cuál es el objetivo que tienen que llegar, la respuesta, y después si hace falta que sea algo muy complejo, una red neuronal, o puede ser un, un algoritmo de regresión para calcular, para beneficiar. Entonces, tener un equipo de inteligencia artificial que se complemente con el resto de las especializaciones y puedan obtener un objetivo en común, ¿no? Esa es la idea. Y como lógico, el ingeniero en inteligencia artificial puede diseñar una red, pero no sabe, no está metido en temas particulares. Siempre va a necesitar un especialista en el tema, ¿no? ¿Se entiende lo que quiero decir, no? No sé. A ver el chat.
Sí, claro, sí, sí.
No, si usted, por favor, el que quiera hablar, que hable, que comente, si no está de acuerdo con lo que estoy diciendo, si no entiende lo que estoy diciendo, que capaz que es muy probable que no se entienda lo que estoy diciendo, porque primero hay que entenderlo a Andrew y después me tiene que entender a mí. Andrew chino, yo no sé. No, pero esa es la idea. Y bueno, que dice que la mejor forma es la capacitación, que una de la capacitación puede ser por este tipo de cursos así, en distintas plataformas, por blogs, que hay mucho material, muchísimo material, que hay que empezar, que no es, y que un ingeniero de software, obvio que necesita menos pasos, igual que si hay un analista de datos, un científico de datos, que pueda llegar a implementar tipo de algoritmo, no es tampoco muy... Yo empecé hace 2 años y medio estudiando Python por mi cuenta y bueno, y ahora estoy trabajando con esto y la curva de aprendizaje es bastante amplia, es bastante, ¿cómo se llama? Es amena al principio, ¿no? Eh, Después, obvio, a medida que uno va avanzando, que se va especializando, cada vez se va abriendo más casos, ¿no? Pero tranquilamente uno puede llegar. Así que con cursos online y con material que hay en blogs. Hay un montón de material, hay un montón, ustedes lo habrán encontrado buscando, googleando, que está lleno. Y bueno, y una de las cosas que nosotros hacemos acá en el centro es tratar de llevar este contenido a la mayor cantidad de gente posible. Bueno, vamos a seguir. Esta es la parte 2.
In the last video, you learned how to execute pilot projects to gain momentum, build an in-house AI team, and provide broad AI training. But if you want your business to not just gain momentum in the short term using AI, but in the long term be a very valuable and maybe even defensible business, what can you do? Let's talk about AI strategy, as well as perhaps important for some companies, internal and external communications relative to AI. To recap, this is the 5-step AI transformation playbook, and in this video, we'll dive more deeply into these final 2 steps. Step 4 of the AI transformation playbook is to develop an AI strategy, which I hope for you may mean to leverage AI to create an advantage specific to your industry sector. One unusual part of this playbook is that developing the AI strategy is step 4, not step 1. When I shared this with many CEOs, a consistent request or piece of feedback I got was, can you please put the strategy as step 1? Because I'm going to figure out what is my company strategy, then want to find the resources, and then I'll execute on the strategy. But I found that companies that try to define the strategy as step 1 before getting your feet wet, before trying out AI and knowing what it feels like to build an AI project, companies like that tend to end up with sometimes very academic strategies that are sometimes not true to life. So for example, I've seen some CEOs copy and paste newspaper headlines into their strategy. We read that data is important, so you say, my strategy is to focus on collecting a lot of data. But for your company, that data may or may not be valuable. It may or may not be a good strategy for your company. So I tend to recommend to companies to start the other steps first, execute the pilot projects, start building a little bit of a team, start providing some training, so that only after you understand AI and understand how it may apply to your business, that you then formulate your strategy. And I think this will work much better for your company than if you try to formulate an AI strategy before your company, including specifically the executive team, has some slightly deeper understanding of what AI can and cannot do for your industry sector. In addition, you might consider designing a strategy that is aligned with the virtuous cycle of AI. Let me illustrate that with an example from web search. One of the reasons that web search is a very defensible business, meaning it's very difficult for new entrants to compete with the incumbents, with the existing large web search engines, is this. If a company has a better product, maybe a slightly better product, then that web search engine can acquire more users, and having more users means that you collect more data because you get to observe what different users click on when they search for different terms, and that data can be fed into an AI engine to produce an even better product. So this means that the company with a somewhat better product ends up with even more users, ends up with even more data, and does an even better product with this link being created by modern AI technology. And it makes it very difficult for a new entrant to break into this self-reinforcing positive feedback loop called the virtuous cycle of AI. Fortunately though, this virtuous cycle of AI can be used by smaller teams entering new verticals as well. So I think today it's very difficult to build a new web search engine to compete with Google or Baidu or Bing or Yandex. But if you are entering a new vertical, a new application area where there isn't an entrenched incumbent, then you might be able to develop a strategy that lets you be the one to take advantage of this virtuous cycle. Let me illustrate with an example. There is a company called Blue River that was acquired by John Deere for over $300 million US. And Blue River makes agricultural technology using AI. So what they did was build these machines that would be towed behind a tractor in a big agricultural field, and this machine would take pictures of crops and figure out which is a crop and which is a weed, and use precision AI to kill off just the weeds but not the crop. So I knew some of the founders of Blue River while they were Stanford students taking my class. And so to get the project started, they actually just used scrappiness and sweat. They used their personal cameras and went out to a bunch of farms and took a lot of pictures of crops in these agricultural fields. So they started to collect pictures of heads of cabbage and weeds around the cabbage. Once they had enough data, starts off with a small data set, they could train a basic product. And the first product, frankly, wasn't that great. It was trained on a small data set, but it kind of worked well enough to start to convince some farmers, some users, to start to use their product, to tow this machine behind the tractor in order to start culling weeds for the farmers. And once this thing was running around the farms through the process of taking pictures of heads of cabbage and killing off weeds, they naturally acquired more and more data. And over the next few years, what they did was they were able to enter this positive feedback loop where having more data allows you to have a better product, having a better product allows you to convince more farmers to use it, and having farmers use it allows you to collect more data. And over several years, entering a virtuous cycle like this can allow you to collect a huge data asset that then makes your business quite defensible. And in fact, at the time of acquisition, I'm pretty sure that they had a much bigger data asset of, pictures of heads of cabbage lying in a field than even the large tech companies had. And this actually makes the business relatively defensible from even the large tech companies that have a lot of web search data but do not have nearly as many pictures as this company does of, heads of cabbage lying in the agricultural fields. One more piece of advice. A lot of people think that some of the large tech companies are great at AI. And I think that's true. Some of the large tech companies are very good at AI. But this doesn't mean you need to or should try to compete with these large tech companies on AI in general, because a lot of AI needs to be specialized or verticalized for your industry sector. And so for most companies, it'll be in your best interest to build AI specialized for your industry and to do great work on AI for your application areas, rather than try to compete or feel like you need to compete left and right with the large tech companies on AI all over the place, which just isn't true for most companies. Other elements of an AI strategy. We are going to live in an AI-powered world, and the right strategy can help your company navigate these changes much more effectively. You should also consider creating a data strategy. Leading AI companies are very good at strategic data acquisition. For example, some of the large consumer-facing AI companies will launch services like a free email service or a free photo sharing service or many other free services that do not monetize, but allows them to collect data in all sorts of ways that lets them learn more about you so they can serve you more relevant ads and thereby monetize the data in a way that is quite different than direct monetization of that product. The way you acquire data is very different depending on your industry vertical, but I have been involved in what feels like these multi-year chess games where other corporate competitors and I are playing multi-year games to see who can acquire the most strategic data assets. You might also consider building a unified data warehouse. If you have 50 different data warehouses under the control of 50 different vice presidents, then it's almost impossible for an AI engineer or for a piece of AI software to pull together all of this data in order to connect the dots. For example, if the data warehouse for manufacturing is in a totally different place than the data warehouse for customer complaints, then how can an AI engineer pull together this data to figure out what are the things that might happen in manufacturing that causes you to ship a faulty cell phone, that causes a customer to complain 2 months later? So a lot of leading AI companies have put a lot of upfront effort into pulling the data into a single data warehouse, because this increases the odds that an engineer or a piece of software can connect the dots and spot the patterns between how an elevated temperature in manufacturing today may result in a faulty device that leads to a customer complaint 2 months in the future, thus letting you go back to improve your manufacturing processes. There are many examples of this in multiple industries. You can also use AI to create network effects and platform advantages. In industries with winner-take-all dynamics, AI can be a huge accelerator. For example, take the ride-sharing or the ride-hailing business. Today, companies like Uber and Lyft and Ola and Didi and Grab seem like they have relatively defensible businesses because there are platforms that connect drivers with passengers, and it's quite difficult for a new entrant to accumulate both a large rider audience and a large passenger audience at the same time. Social media platforms like Twitter and Facebook are also very defensible because they have very strong network effects, where having a lot of people on one platform makes that platform more attractive to other people, so it's very difficult for a new entrant to break in. If you are working in a business with these types of winner-take-all dynamics or winner-take-most dynamics, then if AI can be used to help you with growing faster, for example, with accelerating user acquisition, then that can perhaps translate into a much bigger chance that your company will be the one to succeed in this business vertical. Strategy is very company and industry and situation specific, so it's hard to give strategy advice that's completely general to every single company, but I hope that these principles give you a framework for thinking about what might be some key elements of an AI strategy for your company. Now, AI can also fit into more traditional strategy frameworks. For example, Michael Porter many years ago had written about low cost and high value strategies. If your company has a low cost strategy, then perhaps AI can be used to reduce costs for your business. Or if your company has a high value strategy to deliver really valuable products but at a higher cost, then you might use AI to focus on increasing the value of your products. And so AI capabilities can also help augment existing elements of a broader corporate strategy. Lastly, as you're building these valuable and defensible businesses, I hope that you will also build only businesses that make people better off. AI is a superpower. This is a very powerful thing that you can do to build a great AI company. And so I hope that whatever you do this only in ways that make humanity better off. The final step of the AI transformation playbook is to develop internal and external communications. AI can change a company and its products, and it's important to communicate appropriately with the relevant stakeholders about this. For example, this may include investor relations to make sure that your investors can value your company appropriately as an AI company. Investor relations may also include government relations. For example, AI is entering healthcare, which is a highly regulated industry because government has a legitimate need to protect patients. And so for AI to affect these highly regulated industries, I think it's important for companies to communicate with governments and to work collaboratively with them in public-private partnerships to make sure that AI solutions bring people the benefits it can, while also making sure that governments can protect consumers and protect patients. So this would be true for healthcare, it would be true for self-driving cars, it would be true for finance and many other AI industry verticals. If your products change, then consumer or user education will be important. AI talent is very scarce in today's world, and so if you are able to showcase some of your initial successes, that could really help with talent and recruiting. Finally, internal communications is also important. If you're making a shift in your company, then many people internally may have worries, some legitimate and some less rational about AI, and internal communications to reassure people where appropriate can only be helpful. With these 5 steps, I hope it gives you a vision for how you might be able to help a company become good at AI. If you're interested in reading the detailed AI transformation playbook, you can also download it from this Landing AI website. I hope you enjoyed these 2 videos on the AI transformation playbook. I've seen companies become much more valuable and much more effective by embracing and become good at AI, and I hope these ideas may help you take a first step toward helping your company good at AI. Having said that, I've also seen many common pitfalls that companies run into when trying to implement AI across the enterprise. Let's take a look at some of these common pitfalls in the next video so that hopefully you can avoid them. Let's go on to the next video.
Bueno, había alguien que había preguntado si era para grandes empresas o pequeñas empresas, y bueno, el ejemplo ese de los chicos estos que eran estudiantes de él en Stanford y llegaron a vender la empresa por 300 millones de dólares, no sé cuánto es que hicieron, empezaron con nada, empezaron sacando fotos con el celular y haciendo un algoritmo chiquito y tratar de convencer a alguien que usara el producto y les ayudara para seguir creciendo. Entonces, generar un ciclo donde que en la primera vez sabemos que no va a ser bueno, pero la segunda vez va a ser mejor, la tercera va a ser mejor, la cuarta, y cada vez que vamos generando nuevos datos y vamos reentrenando, vamos generando un sistema más robusto, ¿no? Después, lo que decía es que, bueno, si la inteligencia artificial va a modificar, tenemos que comunicar bien qué es lo que, en qué modificó, en qué podemos hacer, qué no, para adentro y para afuera, ¿no? De la empresa. Y bueno, no sé si alguien quiere alguna pregunta, hacer un comentario, o si no, ¿se entiende? ¿Quedó todo claro? No sé si es de ahora o viejo eso. Bueno, vamos a los obstáculos de la inteligencia artificial deben evitarse.
I hope you'll be able to use AI to build exciting and valuable projects either for yourself or for your company and make life better both for yourself and for others. Along the way, I hope you also manage to avoid some of the pitfalls I've seen some AI teams fall into. Let's go over 5 don'ts and do's for if you're trying to build AI for your company. First one, don't expect AI to solve everything. You already know that AI can do a lot, but there's also a lot that AI cannot do. Instead, you should be realistic about what AI can and cannot do, given limitations of technology, data, and engineering resources. That's why I think technical diligence, in addition to business diligence, is important for selecting feasible and valuable AI projects. Second, don't just hire 2 or 3 machine learning engineers and count solely on them to come up with use cases for your company. Machine learning engineers are a scarce resource, but you should instead pair the engineering talents with business talent and work cross-functionally to find feasible and valuable projects. It is often the combination of the machine learning talent with the business talent that can select the most valuable and feasible projects. Third, don't expect the AI project to work the first time. As you've already seen, AI development is often an iterative process, so you should plan for it to be an iterative process with multiple attempts needed to succeed. Fourth, don't expect traditional planning processes to apply without changes. Instead, you should work with the AI team to establish timeline estimates, milestones, KPIs, or metrics that do make sense. The types of timeline estimates, milestones, and KPIs or metrics associated with AI projects are a bit different than the same things associated with non-AI projects. So hopefully working with some individuals knowledgeable about AI can help you come up with better ways of planning AI projects. Finally, don't think you need superstar AI engineers before you can do anything. Instead, keep building the team and get going with the team you have, realizing that there are many AI engineers in the world today, including many that have learned primarily from online courses that can do a great job building valuable and feasible projects. If you can avoid these AI pitfalls, you'll already be ahead of the game compared to many other companies. The important thing is to get started. Your second AI project would be better than your first. Your third AI project would be better than your second. So the important thing is to get started and to attempt your first AI project. In the final video for this week, I want to share with you some concrete first steps you can take in AI. Let's go on to the next video.
Bueno, es un resumen de todo lo que estuvimos viendo, ¿no? ¿Qué opinan? Porque en definitiva todo lo que dijo, los 5 errores ya lo habíamos visto de entrada. Primero, no creer que la inteligencia artificial puede resolver todo. ¿Qué más era? Que no me acuerdo bien el orden, pero que no necesariamente que tenemos que complementar, no solamente el ingeniero de inteligencia artificial, sino gente que sepa de otros temas, de manejar con un científico de datos, y después que no, ¿cómo se llama? Que no tiene que ser superestrella, que uno que tiene todo el tiempo capacitándose, ¿no? La capacitación es importante y que no necesariamente tiene que ser especialista, estrella, no. Empezar a arrancar y ir aprendiendo a medida que uno va caminando, ¿no? Están ahí, ¿no?
Sí.
Gracias, estamos mirando.
Sí, gracias por favor por hablar.
Sí.
No, pero quiero escucharlo también a ver que, si alguien opina algo que le genera, si le genera una intriga. No me dejen hablando eso. ¿No? ¿Nada? Bueno, continuamos entonces.
Disculpa una cosa.
Sí.
Yo creo que, de acuerdo a la experiencia de ustedes, no la de Andrew, o como quiera pronunciarse,
Andrew, sí.
sí, el tema es cómo uno en una empresa que tiene o que está pensando en aplicar inteligencia artificial en algún proceso, en algún elemento de diseño, de relación con el cliente, cómo puede acercarse o qué debe tener para acercarse a consultores o empresas de inteligencia artificial. O sea que, ¿cómo se tiene que presentar ese proyecto para ver su viabilidad y su
Claro,
justificación?
bueno, mira, como es un tema muy nuevo todo esto de inteligencia artificial, no es que vas a decir, bueno, pongo un aviso en el diario, necesito ingeniero de inteligencia artificial, ¿egresado de dónde? En ningún lado. Entonces, lo que vas a tener que hacer es buscar, primero investigar vos, buscar información, tratar de informarte, y después está como acá, como el centro, eh, hay foros, hay distintos lugares, en blogs, gente que está investigando, que la verdad está muy amena a colaborar y ayudar. Obviamente que como esto es un tema que eh, como va creciendo tanto y hay poca gente y- y se necesita, es como que hay una escasez. Entonces, por ejemplo, acá en el centro está Ariel, está Omar, hay gente como, bueno, Sergio Doncelli, como, yo qué sé, hay mucha gente que yo estuve hablando en la semana de afuera, gente de CONICET, de ingenieros, y que están tratando de, gente que están tratando de implementar, ¿no? En otras, que son de otras áreas y están estudiando, tratar de implementar inteligencia artificial. Entonces, hay un movimiento. Entonces, hay que meterse en este ámbito, y tener un proyecto y tratar de ir armándolo con un grupo, primero, como decían, solo, con un grupo de gente, tratando a alguno que sepa algo de software, que se pueda capacitar, eh, y bueno, y así, de a poquito. No es que vas a encontrar eh, egresados de alguna universidad ingeniero en inteligencia artificial. No, no hay cargo, por lo menos por ahora. A lo sumo un data science o un machine learning, alguien que estudió, algún ingeniero en informática que se especializó en datos,
Lo que
¿entendés?
le quería agregar, Emiliano,
Sí,
eh,
Ariel, no,
¿qué
no te
tal?
cuento.
¿Qué tal? ¿Cómo estás? Lo que le quería agregar era que, viste que Andrew hace hincapié en que dice, te conviene hacer un primer proyecto, aunque no sea un proyecto clave, para generar entusiasmo en la compañía. Entonces, a lo mejor, qué sé yo, un chatbot, algo de visión de reconocimiento facial, cualquier cosa que diga, bueno, ve, esto de inteligencia artificial y funciona. Y que otros departamentos de la empresa digan, ah, sí que hay un grupo de gente que está en inteligencia artificial, bueno, nosotros querríamos hacer esto. O sea, quizás empezar con algún proyecto medianamente simple, que pueda generar entusiasmo, que pueda generar interés, lo que él llama momentum. Y digamos que de alguna manera uno pueda en un lapso de 6 meses, un año, mostrar un pequeño éxito inicial como para entrar con buen pie. Ese me parece que es un gran consejo. Y después la otra es no pensar que es un equipo externo que te va a resolver las cosas, sino de alguna manera, como también dice Andrew y decía recién Emiliano, tratar de armar un equipo donde haya gente de la compañía y gente que a lo mejor puedan ser asesores externos, pero que entre todos traten de evaluar la viabilidad técnica y la viabilidad económica del proyecto, ¿no?
La verdad, Ariel, muchísimas gracias. Dejar las cosas mucho más claras, porque yo a veces me trabo. Pero la verdad que sí, como dice Ariel y como dice Andrew, ¿no? Uno tiene que empezar con algo chiquito, tratando de motivar y aparte ir aprendiendo, porque eso te sirve para... La primera vez te va a salir mal, la segunda te va a salir mejor, la tercera, y ya en un tiempo vas a tener algo bien preparado. Nosotros para las infracciones nos costó, ¿no? Alguien tuvimos un tiempo que los primeros meses nos costaba, ¿no? Era,
Y sí, porque primero que al principio conseguir los datos, que parece una tontería, pero la verdad no es ninguna tontería. O sea, antes de trabajo nosotros dimos vuelta por muchos, sí, los datos están. Después resulta que los datos son el nuevo petróleo, que los tiene un tipo guardado, resulta que los datos no están, después los datos los tenés que conseguir vos. Después vos le decís a la gente, bueno, pero vos me los tenés que clasificar. No, te tenés que ocupar vos de clasificar. Nosotros, en el caso de infracciones, bueno, hubo que agarrar los videos, hubo que dividirlos todos en fotos, y hubo que etiquetar uno por uno las cajitas de los objetos. Fue un enorme trabajo. Y hasta que le agarramos la mano a yo, lo entrenar, y eso fue la primera etapa. Y después creímos que ahí se acababa, que lo demás era fácil, y la realidad es que cuando, bueno, a vos te tocó, Emiliano, cuando uno
Sí,
tenía
no,
que hacer la salida del algoritmo y evaluar si había pasado en rojo o no, eso es toda una historia, todo un montón de algoritmos que no son de inteligencia artificial, pero que es programación que no es tan simple. Y
eh,
pasa
eh,
eso, ¿no?
que también lo mostró Andrew en los ejemplos de Alexa o en el auto autónomo, que hay un montón de tecnologías que van más allá de la inteligencia artificial. Y aparte no es solamente una inteligencia artificial, son dos, tres, cuatro, cinco, varias trabajando juntas que resuelven un problema específico. Así que bueno, seguimos entonces, Ariel, ¿te parece?
Vamos.
Vamos para adelante. Igual ya quedan los dos videos de... Ah, no, quedan un par de videos más, ¿no? Sí.
This week, you saw some examples of what it's like to build a complex AI product, like a smart speaker or a self-driving car. You also learned about the roles and responsibilities of large AI teams and maybe what it's like to build a large AI team, and saw the AI transformation playbook for helping a great company become a great AI company. In case some of this seems daunting, because some of this will take maybe 2 or 3 years to execute, in case some of this seems daunting, it's okay, because the more important thing is that you're able to take the first step. In fact, by taking this course, you've already taken a great first step, so I hope that after this course, you will take also an equally good second step. So in this video, I want to share with you some concrete suggestions for the next step you can take toward AI for yourself or for your company. Here are some initial steps I would urge you to take. Rather than going it alone, consider having friends in your company or personal friends outside work to learn about AI with you. This could mean asking them to take this course with you or after you, or starting a reading group to read some books or other materials about AI. With what you have learned in this course, you will also, especially if you have engineering friends, be able to start brainstorming projects. No project is too small, and it's better to start small and succeed than to start too big and not succeed. Many projects can be done just by you or perhaps by you and a friend, and if you and or a friend take an online course on machine learning, that's enough know-how for you to get started on many potentially very valuable AI projects. In a company, you might also hire a few machine learning or data science people to help out, in addition to providing in-house training to develop the in-house talent. When you're ready to go bigger, you might also try to have your company hire or appoint an AI leader, such as a VP of AI or a Chief AI Officer. But maybe you don't need a very senior AI leader before hiring just a few machine learning or data scientist people to get going more quickly. Finally, I've spoken with a lot of CEOs and boards about AI transformations. And if you want your company to become great at AI, you might also consider trying to discuss with your CEO the possibility of trying to execute an AI transformation. And I think the key question to ask your CEO or your board is, will your company be much more valuable and or much more effective if it was great at AI? And if you and they think the answer is yes, that might be a good reason for the company to try to execute an AI transformation. The different items on this list have varying levels of difficulty to execute, but I hope you will start with what you can and then grow your AI efforts from there. I've seen many people, some technical, many non-technical, help their companies learn about AI and start to use it effectively. After these videos, you now have the concrete tools to do the same, and so I hope you take advantage of them and help your company, help yourself, and help others as well. Finally, we have 2 more optional videos for this week on a survey of major AI application areas as well as major AI techniques. So if you've ever wondered, what do the terms computer vision and natural language processing mean? Or what is reinforcement learning? Or what is unsupervised learning? Please take a look at these videos, since we'll teach you these application areas as well as technologies in the next 2 videos. We made these videos optional because they are a little bit more technical, but after watching them, you will be able to better communicate with AI engineers. So I hope you take a look. Either way, thank you for watching all of these videos this week, and look forward to seeing you in next week's videos.
Bueno, cada vez que se escucha a Andrew es como que va aclarando ciertas cosas, ¿no? Al final resumió todo lo que estábamos hablando antes, ¿no? Así que bueno, ahora vamos a unos videos que son un poco más técnicos, pero tampoco es tanto. Es para mostrarnos los distintos tipos de inteligencia artificial que hay. Espera que-
AI today is being successfully applied to image and video data, to language data, to speech data, to many other areas. In this video, you see a survey of AI applied to these different application areas, and I hope that this may spark off some ideas of how you might be able to use these techniques someday for your own projects as well. Let's take a look. One of the major successes of deep learning has been computer vision. Let's take a look at some examples of computer vision applications. Image classification and object recognition refer to taking as input a picture like that and telling us what is in this picture. In this case, it'd be a cat. Rather than just recognizing cats, I've seen AI algorithms able to recognize specific types of flowers, AI able to recognize specific types of food, and the ability to take as input a picture and classify it into what type of object it is being used in all sorts of applications. One specific type of image classification that has had a lot of traction is face recognition. This is how face recognition systems today work. A user might register one or more pictures of their face to show the AI what they look like. Given a new image, the AI system can then say, is this the same person? Is this you? Or is this a different person? So that it can decide if it should unlock the door or unlock the cell phone, unlock the laptop, or something else based on the identity of the person. Of course, I hope face recognition will only be used in ways that respect individuals' privacy. We'll talk more about AI and society next week as well. A different type of computer vision algorithm is called object detection. So rather than just trying to classify or recognize an object, you're trying to detect if the object appears at all. For example, in building a self-driving car, we've seen how an AI system can take as input a picture like this and not just tell us yes or no, is there a car? Yes or no, is there a pedestrian? But actually tell us the position of the cars as well as the positions of the pedestrians in this image. An object detection algorithm can also take as input a picture like that and just say, nope, I'm not finding any cars or any pedestrians in that image. So rather than taking a picture and labeling the whole image, which is image classification, instead an object detection algorithm will take as input an image and tell us where in the picture different objects are, as well as what are the types of those objects. Image segmentation takes this one step further. Given an image like this, an image segmentation algorithm may output that, where it tells us not just where the cars and pedestrians, but tells us for every single pixel, is this pixel part of this car or is this pixel part of a pedestrian? So it doesn't just draw rectangles around the objects it detects, instead it draws very precise boundaries around the objects that it finds. So in reading X-rays, for example, it would be an image segmentation algorithm that could look at an X-ray scan or some other image of a human body and carefully segment out where is the liver or where is the heart or where is the bone in this image. Computer vision can also deal with video, and one application of that is tracking. In this example, rather than just detecting the runners in this video, it is also tracking in a video where the runners are moving over time. So those little tails below the red boxes show how the algorithm is tracking different people running across several seconds in a video. So the ability to track people and cars and maybe other moving objects in a video helps a computer figure out where things are going. If you're using a video camera to track wildlife, for example, say birds flying around, a tracking algorithm would also be able to help track individual birds flying across the frames of your video. These are some of the major areas of computer vision, and perhaps some of them will be useful for your projects. AI, and deep learning specifically, is also making a lot of progress in natural language processing. Natural language processing, or NLP, refers to AI understanding natural language, meaning the language that you and I might use to communicate with each other. One example is text classification, where the job of the AI is to input a piece of text, such as an email, and tell us what is the class or what is the category of this email, such as is this spam or non-spam email. There are also websites that would input a product description. For example, you might write, I have a secondhand cell phone for sale, and automatically figure out what is the product category in which to list this product. So that would go under cell phones or electronics. Or if you write, I have a new t-shirt to sell, then it would list it automatically under clothing. One type of text classification that has had a lot of attention is sentiment recognition. For example, a sentiment recognition algorithm can take as input a review like this of a restaurant, the food was good, and automatically try to tell us how many stars this review might get. The food was good is a pretty good review, maybe that's a 4 out of 5 star review. Whereas if someone writes service was horrible, then the sentiment recognition algorithm should be able to tell us that this corresponds maybe to a 1-star review. A second type of NLP, or natural language processing, is information retrieval. Web search is perhaps the best known example of information retrieval, where you type in a text query and you want the AI to help you find relevant documents. Many corporations will also have internal information retrieval systems where you might have an interface to help you search just within your company's set of documents for something relevant to a query that you might enter. Name entity recognition is another natural language processing technology. Let's illustrate it with an example. Say you have this sentence and you want to find all the people names in this sentence. So Queen Elizabeth II is a person, Sir Paul McCartney is a person. So in the sentence, Queen Elizabeth II knighted Sir Paul McCartney for his service of music at the Buckingham Palace, it would be a name entity recognition system that can find all the people's names in a sentence like this. If you want to find all the location names or all the place names in a sentence like that, a name entity recognition system can also do so. Name entity recognition systems can also automatically extract names of companies, phone numbers, names of countries. And so if you have a large document collection and you want to find automatically all the company names or all the company names that occur together or all the people's names, then a name entity recognition system would be the tool you could use to do that. Another major AI application area is machine translation. So for example, if you see this sentence in Japanese, AI wa arata na denki da, then hopefully a machine translation system can input that and output the translation. AI is the new electricity. The 4 items on this slide, text classification, information retrieval, name entity recognition, and machine translation, are 4 major categories of useful NLP applications. If you work with an NLP team, you may also hear them talk about parsing and part-of-speech tagging technologies. Let me tell you what these are. Let's take the example sentence, the cat on the mat. A part-of-speech tagging algorithm will go through all the words and tell you which of these words are nouns, which of these words are verbs, and so on. For example, in the English language, cat and mat in this sentence are nouns. So the part-of-speech tagger will label these 2 words as nouns. According to the theory of English language, the word the is a determiner. Don't worry if you've never heard of a determiner before. This is a word from the theory of English language. And the word on is a preposition. So part-of-speech tagger will label these words like that. Well, why do you care? If you're building a sentiment classifier for restaurant reviews, then a pilot speech tagging algorithm would be able to tell you which are the nouns, which are the verbs, which are the adjectives, which are the adverbs, and so on, and therefore help your AI system figure out which are the words to pay more attention to. For example, you should probably pay more attention to the nouns since those seem like important words, maybe the verbs, certainly the adjectives, words like good, bad, delicious are adjectives, and your AI system may learn to ignore the determiners, words like the, which maybe matter less in terms of how a user is actually feeling about a restaurant. A pilot speech tagging system is usually not a final application. You hardly ever wake up in the morning and think, boy, I wish I could get all the words in my sentence tagged. But it's often an important pre-processing step. It's often an important intermediate step in a longer AI pipeline, where the first step is pilot speech tagging or parsing, which we'll talk about in a second, and then the later steps are an application like sentiment classification or machine translation or web search. Now, what is a parser? Given these 5 words, a parser helps group the words together into phrases. For example, the cat is a phrase and the mat is a phrase, and so a parser will draw these lines on top of the words to say those words kind of go together. On the mat is another phrase, and finally, the 2 phrases, the cat, as well as on the mat, these 2 phrases are then combined to form the overall sentence. So this thing that I drew on top of the sentence tells you what words go with what words and how the different words relate to each other. And while a parsing algorithm is also not a final end user product, it is often a commonly used step to help other AI algorithms better classify text or translate it, and so on. Modern AI, specifically deep learning, has also completely transformed how software processes audio data, such as speech. How is speech represented in a computer? This is an audio waveform of one of my friends saying the phrase machine learning. The x-axis here is time, and the vertical axis is what the microphone is recording. What the microphone is recording is little variations, very rapid variations in air pressure, which your ear and your brain then interpret as sound. And this plot shows, as a function of time, the horizontal axis, how the air pressure is changing very, very rapidly in response to someone saying the word machine learning. The problem of speech recognition, also known as speech to text, is the problem of taking as input a plot like this and figuring out what were the words that someone said. A lot of speech recognition's recent progress has been due to deep learning. One particular type of speech recognition is trigger word detection or wake word detection, and you saw this in the earlier video with having an AI system detect a trigger word or wake word such as Alexa or Hey Google or Hey Device. Speaker ID is a specialized speech problem where the task is to listen to someone speak and figure out the identity of the speaker. Just as face recognition helps verify your identity by taking a picture, speaker ID can also help verify your identity by listening to you speak. Finally, speech synthesis, also called text-to-speech or TTS, is also getting a lot of traction. Text-to-speech is a problem of inputting a sentence written in text and turning that into an audio file. Interestingly, whereas text-to-speech is often abbreviated TTS, I don't often see speech-to-text abbreviated STT. One quick example, let's take the sentence, "The quick brown fox jumps over the lazy dog." This is a fun sentence that you often see NLP people use because this sentence contains every single letter from A to Z. So that's A, B, C, all the way up to X, Y, and Z. You can check all 26 letters appear in this sentence. Some letters appear more than once. If you pass this sentence into a TTS system, then you might get an audio output like this.
"The quick brown fox jumps over the lazy dog."
Modern TTS systems are increasingly sounding more and more natural and human-like. AI is also applied to many applications in robotics, and you've already seen one example in the self-driving car. In robotics, the term perception means figuring out what's in the world around you based on the senses you have, be it cameras or radar or LiDAR. Shown on the right is the 3D laser scan or the LiDAR scan of a self-driving car, as well as the vehicles that this self-driving car in the middle has detected in the vicinity of your car. Motion planning refers to finding a path for your robot to follow. So if your car wants to make a left turn, the motion planner might plan a path as well as a speed for the car to make a left turn that way. And finally, control refers to sending commands to the motors, such as your steering wheel motor as well as your gas pedal and brake motors, in order to make the car smoothly follow the path that you want. On this slide, I focus on the software and the AI aspects of robotics. Of course, there's also a lot of important work being done to build hardware for robotics as well. But a lot of the work of AI on perception, motion planning, and control has focused on the software rather than the hardware of robotics. In addition to these major application areas, machine learning is also very broadly used. The examples you've seen in this video relate mainly to unstructured data, such as images, audio, and text. Machine learning is applied at least as much to structured data, and that means these tables of data, some of which you saw in the earlier videos. But because unstructured data, such as images, is so easy for humans to understand, there's something very universal, very easy for any person to understand and empathize with when we talk about an AI system that recognizes a cat. And so the popular press tends to cover AI progress on unstructured data much more than it does AI on structured data. Structured data also tends to be more specific to a single company, and so it's harder for people to write about or understand. But AI on structured data or machine learning on structured data is creating tremendous economic value today, as well as AI on unstructured data. I hope this survey of AI application areas gives you a sense of the wide range of data that AI is successfully applied to today, and maybe this will even inspire you to think of how some of these application areas may be useful for your own projects. Now, so far, the one AI technique we've spent the most time talking about is supervised learning. That means learning input-output or A to B mappings from labeled data, where you give the AI system both A and B. But that's not the only AI technique out there. In fact, the term supervised learning almost invites the question of what is unsupervised learning. Or you might also have heard from media articles from the news about reinforcement learning. So what are all these other techniques? In the next video, the final optional video for this week, we'll do a survey of AI techniques, and I hope that through that, maybe you'll see if some of these other AI techniques and supervised learning could be useful for your projects as well. Let's go on to the final optional video for the week.
Bueno, vamos a pasar al último video, pero lo que vimos acá es todos los ejemplos que después se ven en la especialización, ¿no, Ariel? Sobre el aprendizaje supervisado. Ahora lo que vamos a ver en el próximo video es una... ¿Qué?
Así es, correcto.
Es casi toda la especialización de Deep Learning, todos los ejemplos que se van viendo de aprendizaje supervisado. Ahora lo que vamos a pasar a un video donde nos va a explicar, nos va a mostrar los otros tipos de inteligencia artificial que no son de aprendizaje supervisado.
There are a lot of AI and machine learning techniques today, and while supervised learning, that is, learning A to B mappings, is the most valuable one, at least economically today, there are many other techniques that are worth knowing about. Let's take a look. The best known example of unsupervised learning is clustering. Here's an example. Let's say you run a grocery store that specializes in selling potato chips, and you collect data on different customers and keep track of how many different packets of potato chips a single customer buys, as well as what's the average price per packet that person paid for their potato chips. So you sell some low-end, cheaper potato chips, as well as some high-end, more expensive packets of potato chips, and different people may buy different numbers of potato chip packets in a typical trip to your grocery store. Given data like this, a clustering algorithm will say that it looks like you have two clusters in your data. Some of your customers tend to buy relatively inexpensive potato chips, but buy a lot of packets. If your grocery store is near a college campus, for example, you may find a lot of college students that are buying cheaper potato chip packets, but they sure buy a lot of them. And there's a second cluster in this data of a different group of shoppers that buy fewer packets of potato chips, but buy more expensive packets. A clustering algorithm looks at data like this and automatically groups the data into two clusters or more clusters. And it's commonly used for market segmentation and will help you discover things like that if you have a college student audience that buys a certain type of potato chips and a working professional audience that buys few potato chips but is willing to pay more. And this could help you market differently to these market segments. The reason this is called unsupervised learning is the following. Whereas supervised learning algorithms learn an A to B mapping, and you have to tell the algorithm what is the output B that you want, a unsupervised learning algorithm doesn't tell the AI system exactly what it wants. Instead, it gives the AI system a bunch of data, such as this customer data, and it tells the AI to find something interesting in the data, find something meaningful in the data. And in this case, a clustering algorithm doesn't know in advance that there's a college student demographic and a working professional demographic. Instead, it just tries to find what are the different market segments without being told in advance what they are. So in supervised learning algorithms, given data without any specific desired output labels, without a target label B, can automatically find something interesting about the data. One example of unsupervised learning that I had worked on was the slightly infamous Google Cat. In this project, I had my team run an unsupervised learning algorithm on a very large set of YouTube videos. And we asked the algorithm, tell us what you find in YouTube videos. And one of the many things it found in YouTube videos was cats, because somewhat stereotypically, YouTube apparently has a lot of cat videos. But it was a remarkable result that without telling it in advance that it should find cats, the AI system, the unsupervised learning algorithm, was able to discover the concept of a cat all by itself just by watching a lot of YouTube videos and discovering that, boy, there are a lot of cats in YouTube videos. It's hard to visualize exactly what an AI algorithm is thinking sometimes, but this picture on the right is a visualization of the concept of a cat that the system had learned. Even though supervised learning is an incredibly valuable and powerful technique, one of the criticisms of supervised learning is that it just needs so much labeled data. For example, if you're trying to use supervised learning to get an AI system to recognize coffee mugs, then you may give it 1,000 pictures of coffee mugs or 10,000 pictures of coffee mugs. And that's just a lot of pictures of coffee mugs we would be giving our AI systems. For those of you that are parents, I can almost guarantee you that no parent on this planet, no matter how loving and caring, has ever pointed out 10,000 unique coffee mugs to their children to try to teach their children what is a coffee mug. So AI systems today require much more labeled data to learn than would a human child or than would most animals, which is why AI researchers hold a lot of hope out for unsupervised learning as a way, maybe in the future, for AI to learn much more effectively in a more human-like way, or in a more biological-like way from much less labeled data. Now, we have pretty much no idea how the biological brain works, and so to realize this vision will take major breakthroughs in AI that none of us know yet today how to realize, but many of us hold a lot of hope for the future of unsupervised learning. Having said that, unsupervised learning is valuable today. There are some specific applications in natural language processing, for example, where unsupervised learning actually helps improve the quality of web search quite a bit. for example. But the value today of unsupervised learning is still a lot smaller than the value created through supervised learning. Another important AI technique is transfer learning. Let's look at an example. Let's say you built a self-driving car and you have trained your AI system to detect cars. But you then deploy your vehicle to a new city, and somehow this new city has a lot of golf carts driving around, and so you need to also build a golf cart detection system. You may have trained your car detection system with a lot of images, say 100,000 images, but in this new city where you just started operating, you may have a much smaller number of images of golf carts. Transfer learning is the technology that lets you learn from a task A, such as car detection, and use the knowledge to help you on a different task B, such as golf cart detection. Where transfer learning really shines is if, having learned from a very large data set of car detection, task A, you can now do pretty well on golf cart detection, even though you have a much smaller golf cart data set, because some of the knowledge it has learned from the first task of what the vehicles look like, what the wheels look like, how the vehicles move, maybe that will be useful also for golf cart detection. Transfer learning doesn't get a lot of press, but it is one of the very valuable techniques in AI today. And for example, many computer vision systems are built using transfer learning, and this makes a big difference to their performance. You may also have heard of a technique called reinforcement learning. So what is reinforcement learning? Let me illustrate with another example. This is a picture of the Stanford autonomous helicopter. So it's instrumented with GPS, accelerometers, and a compass, so it always knows where it is. And let's say you want to write a program to make it fly by itself. It's hard to use supervised learning, input to output A to B mappings, because it's very difficult to specify what is the optimal way, what is the best way to fly the helicopter when it's in a certain given position. Reinforcement learning offers a different solution. I think of reinforcement learning as similar to how you might train a pet dog to behave. My family, when I was growing up, had a pet dog. So how do you train a pet dog to behave itself? Well, we let the dog do whatever it wanted to do, and then whenever it behaved well, we would praise it. You go, oh, good dog. And whenever it does something bad, you would go, bad dog. And over time, it learns to do more of the, oh, good dog things and fewer of the bad dog things. Reinforcement learning takes the same principle and applies it to a helicopter or to other things. So we would have the helicopter fly around in a simulator so it could crash without hurting anyone. But we would let the AI fly the helicopter however it wants. And whenever it flew the helicopter well, we would go, oh, good helicopter. And whenever it crashed, we'd go, bad helicopter. And then it was the AI's job to learn how to fly the helicopter to get more of the good helicopter rewards and fewer of the bad helicopter negative rewards. More formally, a reinforcement learning algorithm uses a reward signal to tell the AI when it's doing well or poorly. This means that whenever it's doing well, you give it a large positive number to give it a large positive reward. And whenever it's doing a really bad job, you send it a negative number to give it a negative reward. And it's the AI's job to then automatically learn to behave so as to maximize the rewards. So good dog corresponds to giving you a positive number, and bad dog or bad helicopter corresponds to you giving it a negative number, and then the AI will learn to get more of the behaviors that result in large positive numbers or in large positive rewards. Let me show you a video of the Stanford autonomous helicopter after we did this. This is a video of the helicopter flying under reinforcement learning control. I was the cameraman that day, and when you zoom out the camera, you see the trees planted in the sky. So we actually gave it a reward signal which rewarded the helicopter flying upside down, and using reinforcement learning, we built one of the most capable autonomous helicopters in the world. In addition to robotic control, reinforcement learning has also had a lot of traction playing games. Games such as Othello or checkers or chess or Go. You might have heard of AlphaGo, which did a very good job playing Go using reinforcement learning. And reinforcement learning has also been very effective at playing video games. One of the weaknesses of reinforcement learning algorithms is that they can require a huge amount of data. So if you are playing a video game, a reinforcement learning algorithm can play essentially an infinite number of video games because it's just a computer playing a computer game and get a huge amount of data to learn how to behave better. Or for playing games like checkers or other games, it can play a lot of games against itself and for free get a huge amount of data to feed into the reinforcement learning algorithm. In the case of the autonomous helicopter, we had a simulator for the helicopter so it could fly in simulation for a long time to figure out what works and what doesn't work for flying a helicopter. There's still a lot of exciting research work being done to make reinforcement learning work, even for settings where you may not have an accurate simulator, where it's harder to get this huge amount of data. Despite the huge amount of media attention on reinforcement learning, at least today it is creating significantly less economic value than supervised learning, but there may be breakthroughs in the future that could change that. And AI is advancing so rapidly that all of us certainly hope that there will be breakthroughs in all of these areas that we're talking about. GANs, or Generative Adversarial Networks, are another exciting new AI technique. They were created by my former student, Ian Goodfellow. GANs are very good at synthesizing new images from scratch. Let me show you a video generated by a team from NVIDIA that used GANs to synthesize pictures of celebrities. And these are all pictures of people that had never existed before. But by learning what celebrities look like from a database of celebrity images, is able to synthesize all these brand new pictures. There's exciting work by different teams right now on applying GANs to the entertainment industry, everything ranging from computer graphics to computer games to media, and to just making up new content like this from scratch. Finally, the knowledge graph is another important AI technique that I think is very underrated. If you do a search on Google for Leonardo da Vinci, you might find this set of results with this panel on the right of information about Da Vinci. If you do a search on Ada Lovelace, you also similarly find a panel of additional information on the right. This information is drawn from a knowledge graph, which basically means a database that lists people and key information about these people, such as their birthday, when they passed away, their bio, and other properties of these individuals. Today, different companies have built knowledge graphs of many different types of things, not just people, but also they built these databases of movies, of celebrities, of hotels, of airports, of scenic attractions, and on and on and on. For example, a knowledge graph with hotel information may have a big database of hotels as well as key information about these hotels, so that if you look them up on a map, you can find the right information relatively quickly. The term knowledge graph was initially popularized by Google, but this concept has spread to many other companies. Interestingly, even though knowledge graphs are creating a lot of economic value for multiple large companies at this point, this is one subject that is relatively little studied in academia. And so the number of research papers you see on knowledge graphs seems to be disproportionately small relative to their actual economic impact today. But depending on what industry vertical you work in, perhaps some of the techniques for building knowledge graphs will also be useful for building a big database of information about something relevant to your company. In this video, you learned about unsupervised learning, transfer learning, reinforcement learning, GANs, and knowledge graphs. It seems like a lot, doesn't it? I hope that some of these ideas will also be useful to your projects, and that knowing what these algorithms are will make it easier for you to have fruitful discussions with AI engineers. In this week, we've talked a lot about how AI can affect companies, maybe how you could use AI to affect your company. AI is also having a huge impact on society. So how can we understand the impact that AI is having on society, as well as make sure that we do ethical things and that we use AI only to help people and make people better off? In the next week, we'll talk about AI and society. Thanks for sticking with me up to this point. I look forward to seeing you in the final week of videos for this course.
Bueno, terminamos. La verdad que están geniales los videos. toda la semana, ¿no? Pero
Viste, Emiliano, que viene bárbaro, es un cursazo, ¿no?
sí, la verdad que sí. Y la verdad que te da un pantallazo bien amplio y general de todo, y cada tema que habla es un mundo para profundizar, ¿no? Pero está genial, lo de Gans está genial, de cosas que vi que se hizo, que se hace con Gans es terrible, ¿no, Ariel? Son mortales. Bueno,
Bueno, la
así
idea
que
este año es hacer la especialización de
sí,
GANS.
sí, la tengo que hacer, la tengo que hacer. La tengo que hacer este año, sí.
Y sí, la idea es hacerla de GANS, sí, sí. Esa nos está faltando.
Y Reinforcement Learning, bueno, ya vamos a empezar el martes.
Ah, claro.
Bueno, vamos a pasar al examen. Si tengo, bueno, yo quiero escucharlos ahora, ¿eh? Entiendo y envío la evaluación. 100%, gente.
Impresionante,
Perfecto. ¿Eh?
impresionante.
Mañana, la última semanita del curso y ya terminamos, ¿no? ¿Cómo lo están viviendo el curso este? Es lindo, ¿no?
Muy bueno lo de hoy.
¿Verdad?
Bárbaro, bárbaro. Muy bueno.
Bueno, mañana nos queda el tema que empezamos a hablar hoy, ¿no? De la ética en la inteligencia artificial. Más que nada. Bueno, gente, dejo de compartir y si quieren hacer algún comentario, alguna pregunta, yo estoy unos minutos más y capaz que Ariel también, ¿no?
Perdón, una pregunta. ¿Vas a hacer mención a este GPT-3 en algún momento como de los NLPs?
¿En qué sentido? Sí, te lo
Lo
nombro.
que sobre, digamos, cómo está armado esto, por qué es tal revolución dentro de lo que es Natural Language Processing y todo el resto.
Claro, no. Mira, cuando se hizo este curso no había explotado el asunto de Transformers. Transformers es una red nueva, una estructura nueva basada en la atención. La atención era algo que venía de las recurrentes. Entonces venía de las recurrentes. Entonces eso revolucionó mucho y dio un avance terrible. Porque las recurrentes tenían un problema, bueno, un problema que perdían a medida que iban avanzando en la secuencia, si iban perdiendo información. Entonces se olvidaban. El transformer lo que hace es procesa todo al mismo tiempo, tiene una estructura distinta y lo que no funcionaba antes o tardaba mucho con las recurrentes o tenía con las transformer empezó a funcionar mejor. Y después empezaron a encontrar de que se podían empezar a usar para muchas cosas y con un solo dataset muy grande, entrenándolo mucho, cosas así, un solo modelo podía servir para varias cosas al mismo tiempo. Entonces, ahí vino la revolución. Y GTP3 es la segunda versión, porque antes estaba GTP2 y GTP3, igual todo lo que viene ahora de Natural Language Processing se está haciendo con Transformer. La parte recurrente ya solamente para procesamiento de secuencia de voz, secuencia de tiempo y otras cosas más, pero la mayoría es como que los Transformers están ganando. Una revolución. Esto
Perfecto,
fue
gracias.
el año pasado fue todo eso, ¿no?
Ujú.
No estamos hablando de hace 5 años, fue el año pasado. Este curso salió antes.
Muchas gracias.
Bueno, listo, gente, nos vemos mañana entonces.
Hasta mañana.
Chao, hasta mañana.
Hasta mañana. Hasta mañana.
Mañana.